3.2 Application of Radian Measure. Arc length. The length s of an arc intercepted on a circle of a radius r by a central angle of measure theta radians is given by the product of the radius and the radian measure of the angle. Think of it like the crust of a pizza. So arc length s equals r times theta. So s is the arc length. If I took out one of these arc lengths, so if I really drew it out here, our arc length is the crust of your pizza. Right there. So that's all we're saying. When the formula s equals r theta is applied, the value of theta must be expressed in radians, not degrees. So in order to use the formula, you need to be in radians and not degrees. So a circle has a radius of 18.2 centimeters. Find the length of the arc intercepted by a central angle with measure of 3 pi over 8 radians. So we need to find the length of the arc. That means s. So we need to find s. And that tells us we're using our s equals r theta. That's why we're going to use this formula, because it says to find the length of the arc. So we have to find our radius, which is 18.20. We can just put 18.2. And then we need to find our theta. So our theta must be in radians, and it is in radians, so we're good. Even if it didn't say this, we still know it's radians because of the pi. So we have 3 pi over 8. We use our calculator, just plug it into your calculator, and we get s is approximately 21.44 centimeters. We do 4 significant digits because this is 4 significant digits. Remember, when there's a decimal, we count the 0. Alright, so example 2. A circle has a radius of 18.20 centimeters. Find the length of the arc intercepted by a central angle with measure 144 degrees. So since it says to find the length of the arc, we know we're going to be using s equals r theta. So our radius is 18.20, so 18.2. And our theta, which is the central angle, is 144 degrees. That's not allowed. Theta must be in radians. So let's switch this to radians. We have 144 degrees over 1 times pi over 180 degrees, and we get 4 pi over 5 radians. So that's our theta. 4 pi over 5 radians. So we put this onto our calculator and we get 45.74 centimeters. And again, 4 significant digits because it's 4 significant digits of what they gave us. So why do we use arc length? Why do we find arc length? This next example is a really good reason why. One of the many good reasons why. Finding the distance between two cities. Latitude gives the measure of a central angle with the vertex at Earth's center, whose initial side goes through the equator, and whose terminal side goes through the given location. Reno, Nevada is approximately due north of Los Angeles. The latitude of Reno is 40 degrees north, and that of Los Angeles is 34 degrees north. The N in 34 degrees north means north of the equator. The radius of the Earth is about 6,400 kilometers. Find the north-south distance between the two cities. So this is a word problem. It's an application. When we have applications and things kind of seem weird, like find the north-south distance between the two cities, okay, great. How? Start to draw a picture. So since we're talking about the real world, we're talking about quadrant 1. So we're taking a piece of the globe out right here. So in that quadrant, right, we have never eat soggy waffles. So we have north and east. And then this would be south and west. So on here we have the Earth. It's rounded. And it tells us the radius of the Earth is about 6,400 kilometers. And then it tells us something important about the radius. So let's reread this. Latitude gives the measure of a central angle with vertex at Earth's center, whose initial side goes through the equator and whose terminal side goes through the given location. So the radius is the equator. It tells us the initial side goes through the equator. That's saying the radius is the equator. So from here to here, That's 6,400 kilometers, because that's the equator. And isn't that where the equator is? Isn't it at the largest part of the Earth, which is in the middle? So that is where the equator is. Okay, so it says Reno is 40 degrees north, and LA is 34 degrees north. So that means Reno is more north than LA. So if we drew the land, right, I'll try to. Kind of looks like this. Good enough for me. That's the land. Alright, so it tells me Reno is 40 degrees north. So Reno is more north than LA. Because it's more north. It's 40 degrees north, that's 34 degrees north. So it's more north of LA. So it tells me that Reno is 40 degrees north. That means from the equator to Reno, that's 40 degrees right here. 40 degrees. Then it tells me LA is 34 degrees. So the angle it makes to LA from here to here is 34 degrees. Now it's asking us to find the north-south distance between the two cities. So it's asking us to find this distance right here. That distance right there. Isn't that distance a piece of the Earth's crust? We're finding sector length. We're finding sector length because it wants us to find a piece of the crust, which is the north-south distance between two cities. So that piece of the crust, the theta that goes with it is this right here, but we don't know that theta. We can find it. We can find theta by doing 40 degrees minus 34 degrees, and we get 6 degrees. So the theta that correlates with the sector length is 6 degrees. But we can't use 6 degrees, so we find it in radians. So we have 6 degrees over 1 times pi over 180, and we get pi over 30 radians. And then we have our radius. Our radius is the equator, so let's plug it in. We have S equals our radius, which is 6,400, times our theta, which is pi over 30. We plug it into your calculator exactly the way it looks. Alright, so let's plug this into our calculator. We have 6,400 times pi over 30. And we get 670.206423 or 328. So we get S is approximately 670.20642328. And kilometers, because we're talking about kilometers here. But how many significant digits does it give us? It only gives us 2 significant digits. The whole time it's just 2 significant digits. So if we wanted to round this to 2 significant digits, it would be approximately 670 kilometers. Remember, if there's no decimal, we don't care about the 0. So that is 2 significant digits. So that is our answer. So the north-south distance between Reno and LA is 670 kilometers. You can say about 670. That's more correct. All right, that is the answer. We are done with that example, but I kind of want to give you a little bit of extra information. This has nothing to do with the class, just something interesting. So 670 kilometers is about 416 miles. From city center to city center, so the center of LA to the center of Reno, the actual distance is 479 miles. Pretty dang close, right? Well, that's because I did center to center, but like county or city line to city line, it's probably closer to 416 miles. But I did city center to city center, and we were not off by much. Isn't that crazy? Yeah, that's awesome. All right. Example 4. A rope is being wound around a drum with radius 0.8725 feet. How much rope will be wound around the drum if the drum is rotated through an angle of 39.72 degrees? Say how much rope will be wound around the drum 5 times fast. That is a hard one. That's a tongue twister. Alright, so I'm not really sure what it's asking me to do, so I'm going to start drawing stuff. A rope is being wound around a drum. So a drum is circular. A drum is cylindrical, so it's circular. It has a radius of 0.8725 feet. So the rope is 0.8725 feet. Then it tells us it rotates through an angle of 39.72 degrees. So that means it rotates at an angle of 39.72 degrees. It's asking us how much rope will be wound around the drum, which is the sector length. So we're just using sector length again. So we have S equals our radius, which is 0.8725, times theta. Now, theta has to be in radians, so let's convert it. We have 39.72 degrees over 1 times pi over 180. And we get our theta is 0.6932447789. Use the whole thing. You never round until your final answer. You always use all the numbers until the final answer. So our theta is 0.6932447789. We multiply those two together, and we get S is approximately 0.604856096. Let's round using significant digits. So we have 1, 2, 3, 4 significant digits. So if we rounded this to 4 significant digits, it'd be 0.6049 feet. Alright, example 5. 2 gears are adjusted so that the smaller gear drives the larger one. If the smaller gear rotates through an angle of 225 degrees, through how many degrees will the larger gear rotate? Alright, so it tells us the smaller gear rotates through an angle of 225 degrees. So what that means is it rotates at 225 degrees. It gives us a radius. Then it's asking through how many degrees will the larger gear rotate. So we want to know when this rotates, what is it? What's that measure? They share something. Do you see that they share this part right here? They share that part. They share that little part right there. There we go. They share this part right here. They share arc length, which is known as S. They share the S. They share arc length. So if they share that, don't I have two pieces, but they share something? That's fine. It's a system of equations at this point. It's two things that equal the same amount because they equal the arc length, S. So what we first need to do is find that arc length. Find what do they equal? What is the number that they both equal? So let's find the arc length of what we have. So we can find the arc length of the small one because we have all the information for the small one. So we have S equals R theta. So we have S equals R, which is 2.5. And then theta is 225 degrees. But remember, we don't use degrees. So let's switch that. We have 225 degrees over 1 times pi over 180. And we get 5 pi over 4. So that's our theta, 5 pi over 4. We plug it into our calculator and we get S. So our arc length is 25 pi over 8 centimeters. Now, why did I not use the decimal form? I do not use decimals because we're going to plug this in somewhere. That's not my answer. That's not what it's asking. It's not asking for the arc length. It's asking for the angle of the larger gear. So since it's not asking for that, we don't use decimals. We do not use rounding, nothing. And do you notice in here, it doesn't ask us to round. It doesn't have decimals. So we don't use any decimals until the final answer. All right, how do we get that number with our calculator? I'll show you. So we have 2.5 times 5 pi over 4. Remember, we want the pi, so don't put pi in there. Just put 5 over 4. And then we hit math, enter, enter, and we get 25 over 8. So 25 over 8 and pi always goes on top. Okay, so that's what we just found. We found the sector length. So that little portion right there represents 25 pi over 8. That's what they share. So what we're trying to find is the theta of the big gear. So we know we have the sector length. We have that. We have the radius of the big one. We have the radius of the big one. It's 4.8. What we're trying to find is the theta. How many degrees will the larger gear rotate? Rotation is the angle, that's the theta. That's what we're trying to find. So we have arc length, it's 25 pi over 8. We have the theta of the larger gear, it's 4.8 centimeters. We do not have theta, that's what we're trying to find. So we can solve for theta by dividing 4.8. Are we going to plug this into our calculator? All of it. We don't need to actually work this out at all. So we're going to plug this part into our calculator. All right, there's two ways that we could do this. So if you have a newer calculator, I'll show you one way. If you have an older calculator, I'll show you that way. So if you have a newer calculator, all right, so the whole thing's a fraction. So alpha y equals enter. And then on top, we have another fraction. And so we have 25 pi over 8. And then we're going to have 4.8 on the bottom. And we get remember we're in radian mode right now. So we get theta is approximately 2.045307717 radians. We're working with radians. How do we know we're working with radians? Because we have the pi. So we know we're in radians. So we need to convert this to degrees. So to convert this degrees, so we need to multiply by 180 over pi. So 180, so times 180 over pi. And we get approximately 117.1875 degrees. But we need to figure out how many significant digits we have. So only at the end do you round and use significant digits. So we have only 3 significant digits. So theta is approximately 117 degrees. Area of a sector of a circle. A sector of a circle is the portion of the interior of a circle intercepted by a central angle. Think of it as a piece of a pie. So the shaded region, that's the area, that's the actual pizza that you're eating. Not the crust, the actual pizza that you're eating, the cheese, all that. So area of a sector, the area A of a circle of radius r and central angle theta is given by the formula A equals 1/2 r squared theta, and again, theta is in radians. Again, theta has to be in radians. So example 6, a central pivot irrigation system provides water to a sector-shaped field with the measurements shown in the figure. Find the area of the field. So our formula is S equals 1/2 r squared theta. All right, so we have to identify a few variables. We have to identify our radius, which is 321. So we have S equals 1/2 radius squared, so 321 squared, times theta. So theta is 15 degrees, but remember, we're not allowed to use degrees. We have to convert this. So we're going to convert this to radians. So we have theta is 15 degrees over 1 times pi over 180. And we get pi over 12 radians. And all we do is just plug this into our handy dandy calculator. So we have 1/2, you can just put 0.5, that's 1/2, times 321 squared times pi over 12. And we get approximately S is a, sorry, not S, I keep putting, it's area. Area. We're talking about area. Area is approximately 13488.03536 centimeters, meters, feet. We're talking about meters here. But let's think about how many significant digits we need. So how many significant digits do they give us? 3 significant digits. So we need to round this to 3 significant digits. So I need to have area is approximately, so 3 significant digits, but how do I can't just do 13400, right? Because that's less. So the next number up, because that's an 8, we would round up 13500 meters squared. Because we're talking about area, that's why it's squared.